functions.
The EV Mini Sports lock-to-lock system makes it less of a job to turn the steering wheel than it is for ordinary cars. In this system, steering is directly connected to the tires. Although the car is a bit harder to steer, the driver's intentions are more directly transmitted, making it feel like a race car.
First, the steering wheel.
The line of sight from the driver's seat is very low. Tooling around at 60 kilometers an hour, the car's top speed, the way the car hugs the ground and the single seat point of view give you the feeling of driving a Formula One car. You can feel the speed while taking it easy on the environment. Next to be removed is the upper frame. After this frame is removed, you can see the car's body, which is made of very strong plastic.
It ends up looking like a bathtub.
This is what makes for the comfort of driving an EV Mini Sport. It looks a bit like a relaxing bathtub. Because of the way it's shaped, the car could be designed to keep low to the ground. And the driver can get a sense of stability while driving. Now, let's look at the brakes. The EV Mini Sports brake system is made up of brake discs and brake calipers. For some reason, the brake discs have a lot of holes drilled into them. Here's why.
The brake disc is sandwiched between brake pads, made from material that causes friction. When the brake pads grab the brake disc, fine dust particles are sloughed off. These particles are cleared away through the holes.
When the brake disc and the brake pads rub together, dust particles are produced. The brakes are automatically cleaned as the dust particles get sucked out through the holes and out of the system. The holes also have other functions, such as helping to dissipate heat and reducing the weight of the entire assembly. During lunchtime at Tajima Motors, everyone always eats together.
It's the racing spirit. It's everyone working together as a team. Mealtime is a very important time for communication. That's why we don't eat until everyone has arrived, so even I have to wait. Hurry up! I'm hungry. All right, let's eat. We brothers used to collect parts from old motorbikes and small cars, assemble them, and make go-karts. We'd race them on the paths alongside the rice fields in the countryside. We had this one-seater go-kart, and I wanted him to ride in it too, but there was no place to sit. So I put this board on top of the seat, on top of pipes here and here. Then he could sit on it next to me. Like a sidecar, but the board was in the air. It was like a diving board at the pool. He sat on it holding tight. We drove it a bit and it was okay. Then I drove it faster, and then we came to a curve. I turned and then looked over, and he was gone. He fell into the rice paddy.
From that experience, I've learned the law of inertia. I was there, but the car wasn't. Then I looked up. I saw a nice blue sky.
rear wheel assembly. They've also taken off the torque limiter, which is on the middle of the shaft connecting the rear wheels. The torque limiter is a device that's connected to the left and right sides of the rear wheel shaft. Its function is to adjust the rotational difference between the wheels on the inside and those on the outside when making a turn. It makes the wheels turn more smoothly. It has a mechanism that allows the car to run with a minimum of energy loss.
100% of the drive force is conveyed to the right wheel, but the torque limiter controls the strength of the brake applied to the left wheel. It makes slippage easier.
The torque limiter adjusts how each wheel rotates by loosening the grip on the joints where they're attached. Loosening the grip allows for a little slippage. Both the left and right wheels turn at the same rate when the car is going in a straight line. But when going around a curve, the number of revolutions the wheels on the inside make are reduced to make the car turn smoothly. This is demonstrated by these markers we've put on the axle. As the car turns, the markers rotate at different rates. The wheels on the inside turn at a slower rate than the wheels on the outside. The EV Mini carries the genes of a race car. It deftly combines everything necessary for motoring around a city. Next, we'll take off the front wheels. What's revealed is the suspension system. Shocks are absorbed here so they won't be sent through the car body. It looks like two wishbones put together. Thus, it's called a double wishbone type suspension system. One part of the suspension system, the dampers, is set diagonally. This is the same suspension system used for a Formula One car. In an ordinary car, the suspension coil is mounted vertically. So what's the reason for the change of angle?
Well, it's simpler, more flexible.
A diagonally set damper can contract and change the ratio in relation to the up and down movement of the wheel. As a result, they can protect the car's body from any shocks caused by bumps or ruts or objects in the road. These black bars also serve a special function. You can see that the angle and length of the upper and lower bars are different. Let's look closely at these parts when the car turns. If the bars are parallel and the same length, the tires go up and down in the same plane. But if the bars aren't parallel and are different lengths, the tires move up and down at an adjusted angle. When the car turns, the chassis tilts slightly, but the tires remain in contact with the road throughout the turn, maintaining parallel contact. By ensuring that the tires maintain full contact with the road even when the car is turning, the drive energy won't be wasted, and at the same time, stability is maintained. We're coming to the end of our revelations. Finally, let's look at the car's electrical system. The electrical system is in the back, behind the driver's seat. First, we'll take off a part that only an electric car has, the battery charger.
You plug it into a household wall socket, and 80 volts of direct current, which is about what this car runs on, flows into the battery to recharge it.
Now charges his EV Mini Sport at home. With a 12-hour recharge, he can drive his Mini Sport about 120 kilometers. Next, they're taking out the most important part, the motor controller, which connects the battery to the motor.
It controls how much electricity flows to the motor.
You don't shift gears in an electric car. The speed changes according to the flow of electricity going to the motor. The motor controller adjusts the flow depending upon how hard the driver steps on the accelerator pedal. The power from the motor is transmitted through the belt to the tires. Our barasu process comes to the last step. After removing the car's body, what's left is the red frame of the EV Mini Sport. Just like in race cars, this red frame is made of metal tubes. It's configured like a bird cage. There's a reason for its being shaped like this.
These are called roll bars and roll cages. They have this structure to protect the passengers if the car should roll or flip over.
If the car should flip over, the roll bar will protect the driver. This bird cage is both light and strong. They're usually found only in race cars. This deceptively simple form helps ensure safety. Just as we've laid out the last remaining parts, who should show up?
We've taken apart everything without any problems.
Thanks for the good work.
Monster Tajima has arrived.
Wow, it ended up like this.
There were 117 components in all, and it took about 9 hours to remove them. This electric car has superb environmental performance. It was created by combining racing technology with concern for environmental compatibility. Its DNA comes from Formula One cars. Remarkable structures and surprising mechanisms have been incorporated into it. The Tajima Motor Corporation's EV Mini